device. Using this new orientation, we write down the characters, row by row, in a 14 by 24 grid. You'll notice the text now matches the encoding chart, and all we have to do to generate the K3 ciphertext is rotate the text once more. There you go. The encoding chart even has the word end written in the corner here to mark the end of the ciphertext. But there is one problem with this approach. It leaves out the question mark at the very end of K3. Notice how it's not included in the encoding chart. This has led many to suspect that this final question mark is actually the beginning of K4 rather than the end of K3. Now, an argument against that is that the source text of K3, the Tomb of Tutankhamun, does end with a question mark, and it would of course make a lot more sense for a question mark to fall at the end of a sentence rather than the beginning of one. Sanborn has repeatedly refused to answer whether it belongs to K3 or K4, but has confirmed that it's nothing more than a question mark. Presuming it does belong to K4, the fact the question mark appears at the beginning might be a clue that K4 is written in reverse. Speaking of question marks, remember that inscrutable final sentence of K2? Ever since K2 was first deciphered back in 1992, the phrase ID by rows, or possibly ID by row S, has been a complete mystery. But in late 2005, a cryptos enthusiast by the name of Monet Friedrich was crib-dragging different keywords through K2 when she noticed something odd. If you move the first A of abscissa to the end and plug that in as a keyword, the last sentence of K2 becomes player 2. It wasn't given much attention at the time because, well, discoveries like these are not that uncommon. Shifting letters around and trying different keywords is bound to generate the occasional text that just so happens to be legible. But this time it was different because half a year later, Sanborn informed the cryptos community that he'd made a mistake by omitting an S between this E and W near the end of the K2 ciphertext. If we add that S back in, the final sentence no longer reads ID by rows, but X layer 2. Something that immediately comes to mind is that a palimpsest is a document with 2 layers of text. Anyway, the fact that this omission still produced something legible was pure chance, and it's why it took Sanborn 16 years to detect his mistake. He apparently assumed ID by rows was some sort of cryptographic jargon and didn't realize there was something wrong with the actual code. This does of course raise the rather concerning possibility that the reason K4 hasn't been solved is because it too contains some sort of mistake that Sanborn has missed. You know, I've done my best to distance myself actually from what I wrote. And when K1 through K3 were cracked, I had to go back to my notes to figure out what I'd written. And it's the same with K4 as well. When it's cracked, if it's cracked in my lifetime, I'm certainly going to have to refresh my memory as far as what I wrote. That is a bit concerning. In a subsequent interview, Sanborn said he was pretty sure that K4 is fairly accurate.
Because if there's another mistake in K4, and I don't know if he's worked backwards through that yet.
No, that one's actually safe and sound and fairly accurate.
You sure about that, Tim?
Yes.